नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार दुरुशेट्टी, फैकल्टी ऑफ माइक्रो प्रोसेसर्स बार्क सीरीज को मैं स्वागत कर रहा हूं। जितने लोग लाइव में हैं मुझे एक बार वॉइस कंफर्मेशन कर दीजिए, ऑडियो वीडियो सब कुछ क्लियर या नहीं। आज हम डिस्कस करेंगे, आज का सेशन माइक्रो प्रोसेस का सेशन है। माइक्रो प्रोसेस में हम डिस्कस करेंगे, बार्क में हमको हमेशा क्वेश्चंस आने की चांसेस है माइक्रो प्रोसेस में। सो व्हाट आर द क्वेश्चंस वी आर गोइंग टू गेट इन माइक्रो प्रोसेसर? वी आर गोइंग टू गेट इन 8085 माइक्रो प्रोसेसर, मेजरली 8085 माइक्रो प्रोसेसर पे आ सकता है, and sometimes we are also going to get 8086 basics, and we are also going to get 8051 microcontroller and some programming related concepts, programming, interfacing. So these are the concepts. ये concepts के ऊपर हमको हमेशा क्वेश्चंस आने की चांसेस ज्यादा है। अगर जितने लोग लाइव में है तो मुझे एक बार वॉइस कंफर्मेशन कर दीजिए। गुड इवनिंग विष्णुवर्धन, कहाँ से हो? ओके, सो चलो, let us start. First, before starting the session, let me talk some features. What is actually definition of microprocessor and what is microcontroller? First definition करके खत्म जाएंगे। So microprocessor बोलो तो क्या है? So what is a microprocessor? So microprocessor is nothing but it's a CPU on a single chip. It's a CPU on a single chip. So that is a microprocessor. That is a microprocessor. Okay, so please make a note of that. Anybody is having any problem with audio video? सब कुछ क्लियर है? गुड इवनिंग, एक बार कंफर्मेशन कर दीजिए। Next, let us go for the microcomputer. What is microcomputer? Let us see here. Microcomputer बोलो तो क्या हो सकता है? So if you see microcomputer, whenever a microprocessor is a dummy device. Yes. या थ्योरी के साथ भी करवा सकता हूं, थोड़ा ध्यान से देखो. So this is the microprocessor. When this microprocessor is associated with RAM, ROM, IO ports and timers, then that is what we call as microcomputer. So this is what we call as RAM, this is what we call as ROM, this is what we call as IO, so this is what we call as ports or some external peripherals like serial data communication and all those things. So now when they are interfaced like this, then this is what we call as microcomputer. मैंने माइक्रोकंप्यूटर बोलो तो क्या है? माइक्रोप्रोसेसर अकेला कुछ भी नहीं कर सकते हैं। माइक्रोप्रोसेसर को क्या होता है ना, माइक्रोप्रोसेसर को मेमोरी इनबिल्ट नहीं रहता है। माइक्रोप्रोसेसर के लिए मेमोरी एक्सटर्नल में रहता है दोस्तों। सो ध्यान से अंडरस्टैंड करने की कोशिश करो। माइक्रोप्रोसेसर को मेमोरी एक्सटर्नल में रहता है, माइक्रोप्रोसेसर को मेमोरी इनबिल्ट नहीं है। सो दैट इज अ इश्यू। सो इसकी वजह से क्या होगा, माइक्रोप्रोसेसर विल बी फेसिंग ए प्रॉब्लम ऑफ microprocessor needs an interfacing. Okay, so when a microprocessor interface with RAM, ROM, IO ports, then उसको हम बोल सकते हैं माइक्रो कंप्यूटर बोल सकते हैं. सो माइक्रोप्रोसेसर के लिए एग्जांपल देखो. सो माइक्रो प्रोसेसर के लिए एग्जाम्पल होगा 8085 एंड 8086. ओके, एंड माइक्रो कंप्यूटर के लिए क्या होगा एग्जाम्पल? सो व्हेन इट इज इंटरफेस लाइक दिस, सो एग्जाम्पल होगा मदरबोर्ड एंड कैलकुलेटर. ओके, सो माइक्रो प्रोसेसर के लिए मेमोरी हमेशा एक्सेल रहता है. सो नेक्स्ट कम्स द माइक्रो कंट्रोलर. सो व्हाट इज माइक्रो कंट्रोलर? व्हाट इज माइक्रो कंट्रोलर? माइक्रो कंट्रोलर को हम क्या बोल सकते हैं? सो माइक्रो कंट्रोलर इज डिफाइंड एज an entire microcomputer on a single chip. Microcomputer on a single chip. Microcomputer on a single chip. That means what? On one particular chip, the entire things are fabricated. Yes, bidirectional. IO is bidirectional. Input and output. Input and output bidirectional. इसका मतलब क्या है ना? Input output device के लिए communication रहता है. That is not a matter. I'm talking about the bus. These are the buses. So if you see microcontroller, in microcontroller what happens? There will be microprocessor, a part of CPU, and inbuilt is a part of CPU, and a RAM and ROM and ports, and there is a serial data communication like this. So if you see this, so this is our CPU. There is an inbuilt RAM, random access memory, inbuilt ROM. Okay, so there will be timers. So many features are there, like timers, counters, serial data communication, etc. Interrupts. Okay, interrupts. So these are called microcomputer on a single chip. Microcomputer on a single chip is called as microcontroller. इसका example होगा 8051 microcontroller, Atmega 328 microcontroller, which is called Arduino, and LPC 2148 microprocessor ARM controller. So these are our PIC microcontroller. Also we can take PIC microcontroller. Okay, noted? Yeah, these are the basic theory. Suppose now if you see some features of 8085, if you take the 8085 microprocessor, it is having certain features. It is having certain features. If you see the 8085 features, 8085 microprocessor ka features. It is having 8 data lines. They are D0 to D7. Next, 16 address lines. They are A0 to A15. And the memory accessible to power 16 memory locations. 2 power 16 memory locations means each memory location can store 8 bits. So this is 2 power 6 into 2 power 10 into 8. So this is 64 kilobytes. This is what? 64 kilobytes. Next comes the range of the memory. See the range. The range of the memory is, it is having 16 address lines. So 0000H2, double F, double F. So these are the features. Yes. Hey, hi, 8085B hai. Next. Coming to the 8085 interrupts, 8085 microprocessor has 13 interrupts. These 13 interrupts are classified as maskable, they're classified as hardware and software. Next, they're classified as vectored and non-vectored, and they're also classified as maskable and non-maskable. Okay, so what are the hardware interrupts? So the list of hardware interrupts, if I take trap, we can take hardware interrupt, which is also called as RST 4.5. Next comes RST 5.5, RST 6.5, RST 7.5 and INTR. So these total 1, 2, 3, 4, 5. 5 hardware interrupts, and software interrupts are RST 0, RST 1, RST 2, RST 3, RST 4, RST 5, RST 6, RST 7. Okay. Eight plus 5. So 5 plus 8 total, that is equal to 13 interrupts. Next, vectored and non-vectored. So what are the vectored and what are the non-vectored? Vector means which has certain direction. When interrupt is happened, there is a possibility of getting a ESR. Can anybody tell me what are that? Yeah, tell me. Vectored interrupts, इसमें vector interrupts क्या क्या आ सकता है? All the software interrupts RST 0 to RST 7 and इसके साथ साथ RST 4.5, 5.5, 6.5 and 7.5. So these are 12 total. So these are 8 plus 4, 12. And non-vector is only INTR. So this is non-vector. So total milake, so 12 plus 1, that is equal to 13 interrupts. 13 interrupts. And maskable and non-maskable means whenever interrupt is happened, अगर हमको प्रिवेंट कर सकते हैं उसको हम बोल सकते हैं मास्केबल, अगर प्रिवेंट नहीं कर सकते उसको हम बोल सकते हैं नॉन मास्केबल. सो मास्केबल इंटरप्ट्स में क्या क्या आएगा? मास्केबल इंटरप्ट्स में हमको मिलेगा RST 0 to 7 and trap is the non-maskable, remaining like RST 7.5, 6.5 and 5.5. Okay, and INTR. So trap is the non-maskable. So total 12 plus 1, that is equal to 13. Okay, so total 13 interrupts. So this is all about the 8085 microprocessor. And in 8085 microprocessor, if you go for the instruction set, the classification of instructions that if you see in 8085, the major instructions of 8085, if you take it as data transfer instructions are there, data transfer instructions. Under the data transfer instructions, we can take examples like MVI, MOV, move. See, we can write different types like this. I can write MVI B comma 22. So this is what we call as immediate addressing mode. Or next I can write as move A comma B. These are register addressing modes. Okay. Next LDA 2000. So 2000 is a memory location. So this memory location में जो भी content है उसका content accumulator में आना है. This is called data transfer instruction. Similarly STA 5000 accumulator में जो content उधर जाएगा. So these all are the different types of addressing modes and data transfer instructions. And push and pop. Before that, let me explain the registers of 8085. We have forgot that. So पहले वो तो explain करने दीजिए. So the registers of 8085, or we can call as a programming model of 8085. Programming model of 8085. जितने लोग लाइव में हैं मुझे एक बार कंफर्मेशन कर दीजिए बेटा, सब कुछ ठीक चल रहा है. In programming model of 8085, what are the basic registers and what type of registers are there? So register से कैसा काम चलेगा, जो फंक्शनलिटी क्या है. So जो भी माइक्रोप्रोसेसर है ना, माइक्रोप्रोसेसर का फैमिली में आपको पहले रजिस्टर्स का फंक्शनलिटी करेक्ट होना है. So if you see the registers model, so A is a register accumulator, we call the B and C another register, D and E is another register, H and L another register, SP is another register, PC is another register. Okay, so if you see this, now this is what our accumulator BC, DE, HL, PC. So this is a 16-bit, these are 16-bit, and if you see now, these are 8-bit, this is 8-bit, this is 8-bit, this is 8-bit, this is 8, this is 8, this is also. As a pair we can take, this is the BC as a pair 16-bit, DE as a pair 16-bit, HL as a pair 16-bit. Stack pointer represents the top of the stack. इसके साथ साथ हमको एक flag register भी रहेगा. So this is a flag register. So if you see the flag register is having format of D7, D6, D5, 4, 3, 2, 1. So this is D7, D6, D5, D4, D3, D2, D1, D0. Okay. So this is the carry flag. This is a parity flag. This is the auxiliary carry flag. This is zero flag. This is sign flag. So these are the total five flags are there. One is a carry flag, parity flag, auxiliary flag, zero flag, and sign flag. Okay, SZAPC. Sign flag, zero flag, auxiliary flag, parity flag, carry flag. Okay, so total registers. This is a programming model. So programming model में हमको पूरा registers का information आएगा. So from this, now what I'm going to take, the addressing modes I'm going to take. So what are the different types of addressing modes? If you see, in this addressing modes only I will explain the instructions itself. Move immediate B comma 22. This can be called as immediate addressing mode. This is a register addressing mode. It's a direct addressing mode. So see here, this is what we call as immediate addressing mode. Why? Because the whatever the number is there, that is going to come here. So this is what we call as immediate addressing mode. Next, this is what we call as register addressing mode. Next, this one is the direct addressing mode. So this is also direct addressing mode. Next, push B and push pop DS. These are the also stack addressing modes. We can call these as stack addressing mode. They are working on the stack. These are the different types of registers. Okay. So next classification of instructions on the 8085 is arithmetic instructions. If you go for the next classification, that is arithmetic instructions. Interestingly, 8085 is having only some set of arithmetic instructions. It is not having multiplication and division. So if you see the arithmetic instructions, it is having add is one instruction, add immediate is another instruction, add with the carry is another instruction, next sub is another instruction. Okay, sorry, sub immediate instruction, subtract with borrow is another instruction. Okay, sub a comma b is also another instruction. These are different instructions. So for example, add a comma b I can write, add immediate a comma 22 I can write, add immediate ADC b and I can write, something like that. Subtract immediate means subtract a comma 44 I can write, subtract means a comma b I can write, sorry, subtract with borrow means b. This is sub a comma b. So what is happening here, we see this is contents of the a will be added to the contents of the b and the result is going to be stored in the contents of the a. Next, contents of the a are added to the contents of the 22 and the result is going to be added to the a. Next, ADC with b means the content of the b and the content of the a and the content of the carry flag both are added and the result is going to be stored in the a. Got it? Are you understanding, my dear? Yes. Yes, increment decrement also comes under arithmetic instructions. Yeah. Subtract immediate for, so if you see this now, a contents are subtracted 44 and the result is going to be stored in the a. Subtract with borrow, that means a is subtracted with b and also the carry flag, then the result is going to be stored in the a. Subtract a comma b means a is subtracted from the b and the result is going to be stored in the a. And our friend is telling that INR is there, INR is also there, INX is also there. Okay, so when I say INR B, the B will be incremented, INX B, BC will be incremented. So try to understand very fast. I'm going to explain. This is INX. So this is B plus 1, this is BC plus 1. Okay, same to same with the DCR. So DCR B, DCX B. So this is B minus 1, this is BC minus 1. Okay, wow. So these are the arithmetic instructions. Okay, so these are some set of the instructions, my dear. Any doubts? questions. Fatapat. Try to answer this question. For 8085 microprocessor, the instruction RST6 restart subroutine at address what? See, generally what happens, this is the main program. So if we check, so this is the main program. So in the main program, somewhere if this interrupt happened, RST6 interrupt happened, then what happens now? It jumps to certain ISR. It jumps to certain ISR. So this is the ISR to be executed. So this is what we call as interrupt subroutine. And once that interrupt subroutine executed, again it comes back here, and then it will be like this. So depending upon the type of the interrupt, it has to jump to a particular ISR. So एक इंटरप्ट को एक पर्टिकुलर स्पेसिफिक ISR रहता है, उसको हम बोलते हैं इंटरप्ट सबरूटीन बोलते हैं, एड्रेस भी बोल सकते हैं इसको. So what is that address? So is asking the RST6 restart. So इसके लिए एक ही टेक्निक है, जो भी इंटरप्ट जनरेट हो रहा है उसको नंबर 8 से मल्टीप्लाई करो. सो नंबर 8 से मल्टीप्लाई करें तो क्या होगा? 6 into 8 48 होगा. So this 48 is in decimal. So if you convert into hexadecimal, that will become 30H. Okay, so 30H is the address. So that is the context. So why? Because there is separate location in the memory. In that memory location, its address are stored. These are particular address are stored. So 6 into 8 is 48. So 16 3 is that is the way it is going to be generated. Next. Answer this question. If the accumulator of Intel 8085 microprocessor contains 37H, and the previous operation has set the carry flag, then the instruction ACI 56H will result in dash. So if you see that instruction, this is ACI 56. Okay, so that means what? 56 will be added with the carry, and immediately what is going to be added? 30 plus accumulator. So before this, what is the scenario here? If the accumulator of an Intel 8085 microprocessor contains 37, so A is equal to 37H, and the previous operation has set the carry flag, so carry flag is equal to 1. The instruction ACI 56H, so now 56 has to be added to this. So A is equal to 37, that means 0 0 1 1, 7 means 0 1 1. Next 56 has to be added here, that is 0 1 0 1, 6 means 0 1 1 0. So now if we add it, so this is 1 plus 0 1, 1 plus 1 1 0, 1 plus 1 1 0 plus 1 1 1, 1 plus 0 1, 1 plus 1 1 0, 1 plus 1 1 0, 1 plus 1 1 0, so this is 1. So 8 this, and for that again carry should be also added. So this is the carry, so carry also should be added. So 1 plus 1 1 0, 1 plus 0 1, this is 1, this is 1 0 0 0 1. So now what is the answer? This is 8, and this is 1 2 4 8, 8 plus 4 12 plus 4 18. So this is 8E. So the right answer for this question is 8E. Option A is the right answer. Okay, so simple questions आ सकता है माइक्रोप्रोसेसर से, प्रोग्रामिंग रिलेटेड क्वेश्चंस मिस मत करना क्वेश्चंस को. ओके, अगर जो भी कुछ इंस्ट्रक्शंस के ऊपर आपको क्लैरिटी है तो आप मिस मत करना. ओके, so 8E is the answer. So let us go for the next. Now what is this instruction? In 8085, the DA instruction is used for dash. What is this DA? See, actually DA stands for what? DA stands for decimal adjust of accumulator. Decimal adjust of accumulator. So whenever you are performing addition, the result may be sometimes in hexadecimal. So that hexadecimal value has to be converted to decimal. So उसके लिए हम एक instruction use करते हैं, उसको हम बोलते हैं DA बोलते हैं, decimal adjust accumulator. So option C is the right answer. Next. Which of the following instructions are 3-byte instructions? Suppose if you say move immediate A, so this is move immediate A comma 44. So now this is going to become as opcode and this is going to become as operand. So this is the 2-byte instruction. Is what? 2-byte instruction. Next, LDAXB jump 2050. So if you see LDAXB, so LDAXB is a register addressing mode. Why? Because it is loading the accumulator with the contents of the memory location. LDA means load accumulator. X is there. X means hexadecimal. B means BC register. So this is our BC is a register pair. Suppose BC register is containing as 2000. So it will go to the 2000 memory location. In 2000 memory location, whatever the content is there, that will be moved into accumulator. Okay, like that. So this is a 1-byte instruction. Actually, it's a register addressing mode. It is a 1-byte instruction. Now, whereas jump 2050, jump is a opcode, 20 is a address and 50 is a address. So this is a 3-byte instruction. So हम क्या बोल सकते हैं इसको 3-byte instruction बोलते हैं. Next, move A comma M. This is also register addressing mode. So this is also 1-byte instruction. 1-byte instruction. So the right answer for this particular thing is this 3-byte instructions. Okay, perfect. 3-byte instruction. Yes, Vishnuvardhan. Okay. Now let us move for the next. The content of the program counter. So this is the content of the program counter of Intel 𝐂𝐸85. A microprocessor specifies which one of the following. So program counter always represents the address of the next instruction to be executed. So PC always director to the microprocessor. Okay, PC is always directed to the microprocessor. So program counter, it always represents the 16-bit address of next instruction to be executed. It always represents the 16-bit address of the next instruction to be executed. So address of the instruction being executed, the address of the instruction executed earlier, the address of the next instruction to be executed. So this is the right answer. Now see this one. This question is related to the priority. So priority के ऊपर क्वेश्चन पूछ रहे हैं, उसको कैसे आंसर करना. Yeah. 3 devices A, B and C are connected to Intel 𝐂𝐸85 microprocessor device A has the highest priority. So if you see, first of all, device A has the highest priority. So 3 devices are there. So this is device A, this is device B, this is device C. So this is particular device A, this is particular device B, this is particular device C. 3 devices A, B and C are connected to an Intel 𝐂𝐤𝐬 microprocessor. Device A has the highest priority and device C has the lowest priority. So he has given here 5.5, 6.5. First of all, if you see the priority wise always trap is highest priority. Trap, that is RST 4.5, RST 5.5, RST 6.5, RST 7.5, INTR. So this is the priorities. So highest priority is always number 1 is this. Highest priority is this number 1. RST 4.5 is number 2. 6.5 is number 3. 5.5 is 4 and the least one is this one. So this is the highest priority, very highest priority, and this is a very least priority. Okay, so what is asking, who is having highest priority? Device A is highest priority. So device A should be connected to which interrupt signal? So this is the interrupt signal. So device A should be connected to trap. So this should be connected to trap or RST 4.5. Next, least one is INTR, but INTR is not there. Okay, next, device B 6.5, 4.5 is gone. C has the lowest priority. Lowest priority la 7.5, 6.5, 5.5. So A should be connected to trap. Very good. Next, 5.5, C is the lowest priority. C should be connected to 5.5. So which is the right answer here? So let us take analysis like this here. First one, RST 5.5, next 6.5 and trap. So trap is highest priority, 6.5 is the least. Not like this. So it's a confusing thing. So first of all, trap should be connected, A should be connected to trap. A is connected to trap here. Then B and C are there. C is the lowest priority. C should be connected to 5.5. C should be connected to 5.5. So this is not the right option. So I cannot go for this. In the available things, I cannot go for this. Why? Because C should be connected to least priority. C should be, if A is connected to RST 4.5, C should be connected to 5.5, but C uses that no. RST 7.5 is highest, next to 6.5, next to 5.5. It is correct, I think. So this order is correct. So if you see the order now, I will connect the 7.5 is highest order. This is the RST 7.5. Yeah. So this is RST 7.5. Next, C is the least. Device C has the lowest priority. Device C has the lowest priority. The lowest priority is 5.5. So this is RST 5.5. And device B is the highest, next is middle property. So RST 6.5. Got it? 7.5, 6.5, 5.5. So this is the highest priority. This is the least priority. So this is middle. Done. So option C is the right answer. Yes, Vishnuvardhan, option C is the right answer. 7.5 will be the highest, 6.5. Why? Because I thought trap, but trap is confusing here. So this is not matching for the others. Okay, sure. Very good question. Let us move for the next. This one, see, which one of the following is not a vectored interrupt is asking. So out of 13 interrupts, the classification is done like this. One is the vectored interrupts, other one is the non-vectored interrupts. So if I take vectored and non-vectored, vectored interrupts and non-vectored interrupts. So out of the 13 interrupts, I can take the vectored interrupts. Vectored interrupts means which are having certain direction, vectored interrupts. Another one is non-vectored interrupts. Vector interrupts and non-vectored interrupts. So if you see the vectored interrupts, in these vector interrupts, what are the vector means? They are having certain direction. अगर interrupt generate होने के बाद क्या होगा? Interrupt generation होने के बाद, yes, interrupt generation होने के बाद एक particular procedure को जा सकता है वो, direction है, fixed ISR है. So उसको हम vector interrupts बोलते हैं. Vector interrupts में क्या क्या आ सकता है? All our software interrupts will आएगा, RST 0 to RST 7 आएगा software interrupts, पूरा software. एंड हार्डवेयर में क्या क्या आएगा? हार्डवेयर में RST 4.5, 5.5, 6.5, 7.5, RST 4.5, 5.5, 6.5 and 7.5. Okay, these all are the vector interrupts and non-vector interrupts is only INTR. So question में क्या पूछ रहे हैं? Which of the following is not a vectored interrupt? Not a vectored, so option B is the answer. So option B is the answer. INTR is the answer. Yes. Done. Chalo. Now let us go for another question. Yeah. Which one of the following is software interrupts? So interrupts के ऊपर question कितना रहा देखो. Which one of the following is software interrupt of 8085 microprocessor? So again, 8085 interrupts are 13 interrupts are there. So these 13 interrupts can be classified. 13 interrupts can be classified as software interrupts and hardware interrupts. So 13 interrupts can be classified as software interrupts and hardware interrupts. So if I take the software interrupts, and hardware interrupts. Hardware interrupts are nothing but pins. Okay, so what are they? I will take as RST 4.5, RST 5.5, 6.5, 7.5, and INTR. So this is also called as trap. These are hardware interrupts. Software interrupts such as RST 0, 1, 2, 3, 4, 5, 6, 7. So totally 8. So these are 8 plus these are 5. So total मिला के क्या होगा 13 होगा. Okay, he's asking which one of the following is a software interrupt. So RST7, which one of the following is software? 7.5 is hardware. Next, trap is also hardware. Next, INTR is also hardware. Now RST7 is the software. So this is the right answer. Option B is the right answer. आता है भैया, माइक्रोप्रोसेसर भी आएगा. Okay. Power failure alarm. Suppose if a power failure alarm is there, power failure alarm must be connected to which one of the following interrupts of 8085. So it is an emergency, so it should not be maskable. So it should not be maskable. It should be non-maskable. So it should be not maskable, right? So it's a non-maskable. So non-maskable means should be highest priority. So non-maskable means I can go for trap. So trap is nothing but RST 4.5. That is the trap. Option B. Very good. So let us go for the next question. Answer this question. Interrupt acknowledge. INTA means interrupt acknowledge. The program counter in a 8085 microprocessor is 16-bit register because it counts 16 bits at a time. No. There are 16 address lines. No. It will select the user storing 16-bit data temporarily. 16 address lines. Why? Because 16-bit address bus. Okay. So it's a 16-bit address bus. Program counter is showing as FF2C means it is address of the next instruction to be executed. Suppose program counter value is showing as 3000. So 3000 is address of the next instruction to be executed. It is address of the next instruction to be executed. It facilitated the user storing 16-bit data temporarily. No. Okay. Chalo. Processor status word 8085 microprocessor contains 5 flags. Which of these are the flags? So if you see the 8085 flag register, these are the flag registers. So I can take this as D7, D6, D5, D4, D3, D7, D6, D5, D4, D3, D2, D1, D0. So this is D7, D6, D5, D4, D3, D2, D1, D1. So first one, carry flag. This is parity flag, auxiliary carry flag, zero flag, and sign. Okay, sign flag, zero flag. So this is what we call as sign flag, zero flag. This is what we call as auxiliary carry flag, and this is what we call as parity flag. And this is what we call as carry flag. Okay, so processor sign, zero, auxiliary, parry, carry. So this is the right answer. We don't have the overflow flag here. Overflow flag is not there in the 8085. Option A is the right answer. Some more questions, will take it from the gate. Let us solve some good questions from the 8085 microprocessor majorly. Yeah, answer this question. In a microprocessor, the register which holds the address of the next instruction to be fetched is called program counter. So PC always represents the address of the next instruction to be executed. Next, see, in microcomputer, wait states are used for what? In microcomputer, why the wait states are used? So generally, wait states are used to communicate with the slow peripherals. Microprocessor is a fast device. अगर आपके पास कोई स्लो डिवाइस है तो स्लो डिवाइस से कम्युनिकेट करने के लिए हमने वेट स्टेट्स इंट्रोड्यूस कर से, क्योंकि हमने जो डाटा दिया है वो डाटा रीच हो गया नहीं हमको पता नहीं. We expect the data has reached by third clock cycle. By the end of the third clock cycle, agar data is not reached, then the microprocessor has to introduce the wait states. So make the processor wait during DMA operation. It is not only related to DMA operations, so isko cancel kar sakte. Make the processor wait during a power interrupt processing? No. Make the processor wait during a power shutdown? No. So interface slow peripherals to the processor. So it is to communicate with the slow peripherals. So option D le sakte hai. Option D, interface slow peripherals to the processor. Let us go for the next question. Answer this question. If the memory chip size is 256 cross 1 bits, if the memory chip size is 256 cross 1 bits, then the number of chips required to make up 1 kilobytes memory is dash. See, one memory chip size is like this, 256 cross 1. This is 256 cross 1. That means 2 power 8 cross 1. Okay, then the number of chips required. So how many number of such chips are required to make a big size of how much? 1 kilobyte. 1 kilobyte. That means 2 power 10 cross 8. So the n will be equal to, this is 2 power 10 cross 8, the whole divided by 2 power 8 cross 1. So that will be now how much? This is 2 power 13. 2 power 8 means 2 power 3. 2 power 13 divided by 2 power 8. So 2 power 13 minus 8, that is 2 power 5. That will become as 32. So the right answer for this is 32. Option A is the right answer. So 32 number of chips. Okay. Also answer this question. Memory chips also one important question. Try to answer this question. Okay, so how to answer this particular question? See, a memory system of size 16 kilobytes. How much? 16 kilobytes is required to design using memory chips which has 12 address lines and 4 data lines. So ध्यान से देखे तो, so this is particular address, this is particular memory chip है. एक memory chip है, इसका कितना address lines है? देखो address lines is unidirectional and data line is bidirectional. So this is the data lines. Okay, so it is having 12 address lines and 4 data lines. So that memory chip can be represented as 2 power n cross m, I told you, where n is the number of address lines, m is the number of data lines. So how many number of such chips are required? How many number of such chips are required to make a memory of how much size? 16 kilobytes. 16 kilobytes. 16 kilobytes means this is 2 power 4, this is 2 power 10. So this is 2 power 4, this is 2 power 10, and this is 8. The 14 address lines. How many number of such chips are required? So I can write like this. N is equal to 2 power 16 kilobytes divided by this much. How much? 2 power 12 cross 4. 12 address lines and 4 data lines. 12 address lines and 4 data lines. So from this, what I can write? This is 2 power 4. This is k. So 2 power 4 into k means 2 power 10 into b means 8 whole divided by this is 2 power 12 cross 4. Got it? So total kitna hoga? So this will become as 4 plus 10, 14 plus 3, 2 power 17, the whole divided by 2 power 2, 2 power 14 hoga. So 2 power 17 minus 14, so that it will become 2 power 17 minus 14, 3. So 2 power 3 means 8 hoga. So the right answer is 8. So very good question, 8 chips. समझ में आपको? So these are the perfect questions and perfect answers. क्योंकि बार्क में माइक्रोप्रोसेसर को अच्छा वेटेज है, क्योंकि बार्क के लिए आईएएस का सिलेबस भी वेटेज दे सकते हैं. यस, 8 आ सकता है ना, कई सारे बीडीए हो गया, 8 आ सकता है. क्योंकि देखो 4 प्लस 10 14 प्लस 3 17, 12 प्लस 2 14, 17 माइनस 14 3 होगा. सो 2 पावर 3 मीन्स 8 होगा आंसर. ओके, answer this question, my dear. चलो, if you see now a microprocessor with a 12-bit address line. So if you see, if any microprocessor is having 12 addresses, the number of memory locations, so the number of memory locations are nothing but 2 power 12. So this is 2 power 12. One memory location can store 8 bits. Always remember, हमेशा एक memory location में अगर specific नहीं दिए तो हम किसका ले सकते हैं? 8 bits ले सकते हैं. So 2 power 12 बोल तो कितना होगा? 2 power 12 means I can write 2 power 2 cross 2 power 10 like this into 8. So this is 4 KB होगा. So 4 kilobytes is the right answer. Option D is the right answer. 4 kilobytes is the right answer, my dear. So let us go for another question. Good questions, programmatical questions कर सकते हैं हम. Try to answer this question related to rotate instruction. The content of the accumulator of 8085 microprocessor after execution of the following instructions will be dash. Move immediate A comma A7. So first what happens, A will become as A7. A7 means what? A means 1010. 7 means 0111. Okay. Next RA with A. So again A. So 10100111. So what is the OR operation? So the OR operation makes, if any one of them is equal to 1, output will be 1. Okay. So this will be 1, this will be 1, this will be 1, 0, 0, this will be 1, 0, 0. Any one of them is 1, output will be 1. Next RLC पूछ रहे. RLC means what? Rotate left without carry. In 8085 microprocessor, if C is there in the instruction, उसको हम बोल से without carry. If C is not there, with carry. So without carry means first of all left side. So there will be no carry here. So this carry flag is equal to 0 first of all. And this is 1, 0, 1, 0, 0, 1, 1, 1. So we have to rotate. So RLC means what? LSB is going to be shifted towards MSB. It is going to be shifted to MSB, and MSB is going to be shifted to carry. Okay na? And without carry rotation na, so that means MSB will come back to LSB. LSB will be shifted to MSB, MSB will be shifted to carry, and MSB will be come back to LSB. So now if I am taking this, this will be here. So this will be switched like this. So this will be 1. So this will be 1. This will be 1. Okay. So this comes here. This comes here. This comes here. This comes here. 0. And this comes here. 0. This comes here. 1. This comes here. 0. And MSB will be going to carry. But carry will not involve the rotation. This MSB only will come back. So this is 1. So now what happens? This is 4. So if you see now, this is 4 and this is F. So right answer is 4F. Okay. So the right answer for this particular question here is what? 4FH. Option B is the right answer. Miss mat karna questions ko. सी कैसा आएगा यार? 4F आएगा ना? With carry means what yaar? With carry means carry also involved. With carry means what? LSB will be shifted to MSB. MSB will be shifted to carry, and carry will come back to LSB like this. LSB will shift to MSB, MSB to carry, carry will be come back to LSB like this. Carry is also involved, but that is 8085. In 8085, for that instruction is just rotate left, ROL. So this is ROL, whereas this is RLC. That is the interesting thing 8085. अगर इंस्ट्रक्शन में C है तो एग्जीक्यूशन में कैरी को रोटेशन में यूज नहीं कर सकते. अगर इंस्ट्रक्शन में C नहीं है तो केवल रोटेशन यूज कर सकते. बस समझ में आप? क्वाइट ऑपोजिट. इंस्ट्रक्शन में C है तो रोटेशन में C को नहीं यूज कर सकते. इंस्ट्रक्शन में C है लेकिन रोटेशन में कैरी इज नॉट इन्वॉल्व. इधर इंस्ट्रक्शन में कैरी नहीं है, रोटेट लेफ्ट, but carry is involved. That is the interesting thing. Got it? With the carry, mnemonics will be this 0 will come here, this 1 will go here, 0 will come here, 1 1 1 0 will happen. E will be coming. This 1 will be coming here and the 0 will be coming here. This 1 will go to carry and the content of the carry will be coming here. Okay, then it will become 1110. Okay, got it? Chalo. Now let us move for the next questions. Try to answer this question. Consider the following execution instructions of 8085 microprocessor. LXI H01FF SHLD 2050. After execution of the contents of the memory locations 2050 and 2050 and the register HL will be dash. See, first of all, when I say LXI H01FF. So here try to understand. First of all, you have to understand this instruction. I means immediate. X means we have to take hexadecimal. Pair we have to take. H ki proper pair is what? L. So immediately whatever is there that should be loaded. So 01FF. That means H is 01, L is FF. So if you take the memory location, this is the HL memory location. So HL always represents a memory location, na? HL always represents a memory location. So this is 01FF. So the next memory location is adding +1. If we add +1, F ki +1 add yeste, this will be +1. So this will become 2000. So this will become as 2000. So what will happen is this will become 2000. 2000 like this. Okay. SHLD means what? SHLD store. SHLD means, so it is a double. So the contents of the 2050 and the contents of the 2051, the 2050 and 2050 HL will be dash is asking. So again I will go for memory location 2050. So this is 2050 and this is 2050 double. SD means double. So this is 2050 and this is 2051. So what we have to do now, the L has to be coming to the 2050, store the contents of the HL into 2050 memory location. So lower memory location FF will come to this, higher memory location this will come to this. So this will become as FF, this will become as 01. So 2050 will become as FF, 2051 will become as 01 and H will be as it is, L will be as it is. So option C is right answer. Got it? Option C. It's a very good question, quality question. Chalo. See, some more points I want to talk about 8086 microprocessor also. So sometimes in exam, of course, they will be asking the questions on 8086 microprocessor also. So if you see the 8086 microprocessor, so what are the 8086 microprocessor? 8086 microprocessor has 16 data lines, okay, and it has 20 address lines. 16 data lines and 20 address lines. 20 address lines. So 20 address lines means it can access up to 2 power 20 memory locations. 2 power 20 memory locations. So comparatively 8085, 8086 is having some extra features. 8085 is having only 8 data lines and 16 address lines. 8086 is having 16 data lines and 20 address lines. 20 address means 2 power 20 memory locations. 2 port 20 memory location means one memory location can store 1 byte of the data. So that becomes as 1 megabyte. 1K, that is 1 megabyte is the space, memory space. One memory. Done. And if you see the range, it will be having 20 address lines. So the range will be 5 zeros because 1 zero represents 4 zeros. This 1 zero represents 4 zeros. Like the 5 zeros to 1 F. So this is what we call as 5 ECE. Please make a note of this list. Okay. So if you come to the 8086 programming model, 8086 programming model, if you see 8086 programming model, also some important features are there. So what are the programming model features? It is having registers. First of all, it is having certain segment registers. So what are the segment registers? Code segment, data segment, stack segment, extra segment. And we are having the general purpose registers like GPRs. So what are the GPRs? They are AX, BX, CX, DX, source index, destination index, base pointer, stack pointer, instruction pointer, and a flag register. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 registers total. Okay. So this is instruction pointer, same like program counter. And these registers are divisible registers. So these registers, AX is divisible, BX is divisible, CX is divisible, DX is divisible. So this is AL, this is AH, this is BL, this is BH, CL, CH, DL, DH. Okay, so please make a note of this register. What full form? See, this is the general purpose register, which is what we call as general purpose register. General purpose registers. Okay, this is the code segment. This is what we call as code segment register, data segment register, stack segment register, extra segment registers. Accumulator, base, count, data. Source index, destination index, base pointer, stack pointer, instruction pointer. And flag registry is having 16 flags, total 16-bit register. 16-bit register, but actively we are using 9 flags. 9 flags. So these 9 flags can be controlled, can be categorized like this: 6 plus 3. 6 are the status, 3 are the control. So what are the status? Let us take the status flags are carry flag, parity flag, auxiliary flag, carry flag, parity flag, auxiliary flag, 0 flag, sign flag, overflow flag. Control flags are direction flag, interrupt flag, trap flag. Okay, DIT. Okay, so this is a direction flag, this is a interrupt flag, this is a trap flag. Okay, na? So please make a note. These are flag register. Please note down all these things. Chalo. Similarly, I will tell some of the features of 8051 microcontroller also. If you take the 8051 microcontroller is also having certain features. 8051 microcontroller is also having certain features. So registers models, you should have a clarity. Okay. Yeah. What are the features of microcontroller? 8051 microcontroller is having 8 data lines. It is having 8 data lines. And it is having 16 address lines. 18 data lines and 16 address lines, and it is having 4 KB internal ROM on chip. Next, it is having 128 bytes RAM. 128 bytes ROM on chip. Sorry, RAM. On chip, inside memory. That is the beauty of microcontroller. Microprocessor में feature नहीं है. Microprocessor में feature नहीं है. Microcontroller में feature है. Now, if you see, it is having 64 KB ROM, which is the half chip, and here also you can take 64 KB RAM, which is treated as half chip. Okay, so please make a note of these particular points of the 8051 microcontroller. Okay, done. So please have a note of these all points. And we're having certain special registers. We're having two timers. So what are they? Timer 0, timer 1. Both are 16-bit timers. Timer 0 is divided as this is timer low, timer high, timer low, timer high. एक्सक्लूसिव कंटेंट कहाँ भी नहीं मिलता आपको, गेट में नहीं है ना. एंड टाइमर्स को ऑपरेट करने के लिए रजिस्टर्स है टी मॉड रजिस्टर एंड टी कॉन रजिस्टर. Timer mode register, timer control register. Next, to perform the serial data communication, we're having the two registers. One is the SBUF, serial buffer, and serial control. And related to interrupts, we're having interrupt priority and interrupt enable, and we're having the program control registers. Okay. In addition to this, we also have ports. So what are the ports we have? If we check the ports, we're having port 0, port 1, port 2, port 3. Port 0 is having features port 0.0 to 0.7. This is 1.0 to 1.7, 2.0 to 2.7, 3.0 to 3.7. Got it? So these are the basic registers. Enough for today. Okay, so with this, any doubts you can ask me. So please prepare that. Please prepare along with the 8085, 8086 basics and 8051 microcontroller basics also prepare करके जाओ, क्योंकि गेट एग्जाम में हमको माइक्रो कंट्रोलर्स 8051 एंड 8086 पर इतना क्वेश्चंस नहीं है, लेकिन यहाँ आने की चांसेस ज़्यादा है. ओके, इनफ फॉर टुडे. चलो, थैंक यू.